Welcome to Algebra 1. Your first unit is going to be dealing with expressions, equations, and functions. So before we start our first lesson of this unit, on the screen you can see it says translate this English statement, which is today is the first learning day. So if you were to translate this in Spanish, you would say hoy es el primer día de aprendizaje. Sorry if I butchered that. French is my first language. If you were to translate that in French, you would say aujourd'hui est le premier jour d'apprentissage. So what we just did was translate an English statement into Spanish, French, and it can be translated in any other language. So this brings us to our first lesson, which is the objective. Well, the title is Algebraic and Verbal Expression, and the objective is how do we write mathematical, algebraic, mathematical, and verbal expression. So let me make this bigger. Alright, so we're going to learn a few vocabulary words dealing with this lesson. First, algebraic expression. It's the sums and or products of numbers and variables. Variables are symbols used to represent unspecified numbers or values. It could be any letter it can be any letter in the alphabet. So for example, you have 5x, you got 3x minus 7, and then you have 4 plus p over q. So any variable can be used, but if you use whatever you start with, you have to end up with it when you're solving for that variable. Term, a part of an expression that may be a number, a variable, or a product or quotient of numbers and variables. So as we can see in the three examples below, we have 2x plus 4. It has two terms, 1 and 2. We have 3x squared plus 2x minus 1, which has three terms, one term, 2, and 3. And then 5, it's only one term. Factors, quantities being multiplied in an expression. You're going to hear that when we're dealing with multiplying variables and numbers or numbers together or trying to find factors of a bigger number. So factors are basically two or more numbers multiplied to each other to give you the product. Product is the result of multiplying factors. So the first question is, what are the factors of 7y? You notice that you have a number, 7, and then you have y. So it would be 7, oops, there's a little bit of a lag here. Let me get that out again. So we have 7 and y. There's two factors, and that's our factors. How can we write the expression in another way? You could write it y7. You could write it as y times 7 with a dot. You could put parentheses to show that you're multiplying these two factors. Alright. Power. Power is an expression that contains an exponent. So you got the base, which is x, and then the exponent, which is a superscript. That's what you call it when it's up on the top near a variable or number, which is the exponent. So the base plus the exponent together gives you a power. So if you had something like 7 to the second power, this is a power. And since we broke it down to the two factors that create the power, we got base, the number that is used as repeated factors. So that means how many times you're going to multiply the base, and in this case 7. This tells you how many times you're going to multiply it. And then exponent is the number to indicate the number of times the base is used as a factor. So you're going to multiply 7 2 times. If it was 7 to the third power, you're going to multiply it 7 3 times. Next one is algebraic expression. So basically it's a translation into words or algebraic expression that can consist of different operations, numbers, and variables. All right, so when it comes to translating expressions, algebraic expressions, verbal expressions, you have to look for keywords. So with addition, we have verbal phrases such as add, or you can have more, increase, there's other ones, sum. So these are just a few. If there's more that you know that is attached to addition, that's great. But sometimes you see these that tells you, okay, you're going to be adding. Subtraction, you'll see words like decrease or less than or minus, which is a common one, and of course the word subtract. So those are a few of them. For multiplication, words like times, or if you see the word product, the word multiply, those are a few that they would use. And division, you'd see quotient, or the word by, like divide by. And I should put divide by. Or the word per. So those are a few. You may know some others, but these are just a few that you would see. Now, it says, how would we express let me see, there's one here. These algebraic expressions as verbal expressions. So we have 3x to the fourth power. So basically, when you're translating an algebraic expression into a verbal, everything has to be into a word. So there could be different ways of doing this. We could write 3 times x to the fourth power. That's one way you can write it. There's other ways that you can write it. You could say the product of 3 times, actually the product of 3, and I'll remove this one. Actually, let me erase that 3 instead of using times because I used it already. So 3 and x to the fourth. That's another way that you can write it. Okay, so we have another example. 5z squared plus 16. You could say the sum of 5 times z squared and 16. So you could write that. So the sum of 5 times z squared and 16. Or you could say 16 this is 1, this is 2, 16 more than 5 times z squared. So there are many ways to interpret this verbally. You have to use the words so that way if someone were to read it, they could easily translate it algebraically. All right, so the next one is example that is asking us to write an algebraic expression. So the first one says a number t more than 6. So we have the number which is t because we don't know what number it is, more than. So we know that we're adding. So it would be t plus 6. I'll just make it t so that way we can distinguish the plus. And we do that again so we can distinguish the plus and the t as they both look alike. So let's go back to our pen. There you go. 6 plus t plus 6. Next one, 10 less than the product of 7 and f. Alright, so we have 10. Less than, we know it's subtract. The product. Product means we're going to multiply. So when it comes to a product, it's going to be 2 or more numbers. So the product of 7 and f. You see the word and, so that's another thing I'm going to go back to, that you could put, went back too far. You could put and as for addition. And I forgot here, subtraction, you could put difference. So when you see and, you think, oh, plus, but you have to realize this is product. Look at what's first, product of. So that means you're going to have whatever numbers or variables that you're going to multiply to give you the product. So don't get trapped by that and assume that it's going to be 7 plus f and then you're multiplying this. Pay attention. I know it's tricky, but the more you do this, the better you get. So it says 10 less than the product of 7 and f. So we have 7 times f. You can put the dot for multiplying, the x for that, but I'm just going to write it 7f. Same thing as f, 7 times f. And it says less than, minus 10. Most of you might put 10 minus 7 times f. When you see the word less than, you have to switch your terms because it's saying that 10 less than something. That means something that exists and you're taking 10 less of it. So that means you would have to subtract 10 from whatever was there first. Because if you put 10 minus 7f, it doesn't match up to what was written. Because then you're telling me that 7f is less than 10. So that's one of the ones that most students get tripped up on. Alright, so the next one, 2/3 of the volume v. 2/3 of. Of means multiplying. So 2/3, you know that's a fraction, of the volume v. You could write it like that, or again you could write it as parentheses, or you could just put a dot to show multiplication. W more than 3. W plus 3. There's that less than. W less than 3. That means 3 minus W. So anytime you see this, so I'm just going to highlight that. Anytime you see this, that means switch the order of the terms. So this came first, but you know it's going to be behind because you're taking W away from 3. Alright, the next one says R decreased by 2. Some of you might switch this thinking that 2 minus r, but you already started with r and it's being decreased. It's being subtracted by 2. So when you see that decrease by, that means you had something and it's going to be taken away by whatever the last thing is, in this case, which is 2. And we have the product of r, 5r and s. So it's 5r times s, or you could write it as 5rs. Then you have the next one, twice t. Twice means 2 times, decreased by 10. I'm going to subtract 10 from this term. So 2x minus 10. Then we have diminished. That was another one. Diminish, when you diminish something, you make it less. So it's subtract by 4 times n. Times, you know it's multiply. So 25 diminished. So it would be 25 minus 4n, 4 times n. So again, big difference between diminished by, decreased by, and less than. When you see something, if it deals with minus and it says decreased by, diminished by, you keep the order of the terms. You don't have to switch it. But when you see less than, you switch it. So remember that. Then we have the sum of t and u. So sum, we know it's plus. And they give us 2 terms that we're going to be adding, divided by 6. So we have t plus u divided by 6. Then we have 100 decreased by, 100 decreased by, that's minus, decrease, by twice, that means twice, 2 times, twice, the sum of x and 5. The sum is plus. So we know that twice we're going to be multiplying the sum of these 2 numbers. So it would be parentheses x plus 5 close parentheses. If you were to write it 100 minus 2x plus 5, it would not be the same as what was read, what was translated, what has to be translated. So be careful. Then we have twice, which is 2 times, and then the sum of y, x and y. So it'd be 2 times the sum of these 2 terms, x and y. Alright, so some were tricky, some were easy, but again, when you get used to seeing this over and over again, it becomes second nature. Right, so it says write an algebraic expression for each verbal phrase. I'm going to switch to select. Now, it says the product of 3 and n. We got that word, product. We know we're going to be multiplying. They give us 2 factors, so it'll come out to 3n. The quotient of a number n and 3. You look at n, you're like, oh, plus. But wait, look at what's first, quotient. If you go back to the chart, we had that word quotient, meaning divide. So we're dividing 2 numbers, n and 3. So n divided by 3, or you can have it as a fraction, n divided by 3. C cubed. C cubed. What's cube? Cube means to the 3rd power. So it would be c to the 3rd power. Then we have the product. We already saw product. We know we're multiplying. We're multiplying 2 factors, n and 9. So it would be n times 9, or you could write it as n 9n. Let me write that. It could also be 9n. Same thing. Next one, we have 9 more than 7. So you could write it as 7 plus 9, or you could write it 9 plus 7. I mean, literally, it would be 7 plus 9 because you're doing 9 more than what's already there. But with addition, it's a commutative property. That's what we're going to learn later on. Commutative means that you can switch the order of the numbers when you're doing addition. 29 decreased by 10. Remember, you have a number that you're starting with, and you're decreasing it by another number. So 29 minus 10. 5 squared. Squared, we saw that in the chart. 5 to the second power. 4 less than, there's that tricky one. 4 less than n. You're starting with n, and you're taking 4 away from it. So it'd be 4 less than what you started with, which is n minus 4. We have the product. We've already seen that, so we know it's either n times 12 or 12n. n more than 12. So you would have 12 plus n or n plus 12. Okay, so now we did algebraic to verbal. Now we're doing algebraic, we did verbal to algebraic. Now we're doing, okay, I'm so confused here. Start again. So we did verbal to algebraic, and now we're going to do algebraic to verbal. So for this one, it says we have a W, and then we have the minus sign, and we have 1. There's many words you can use for subtraction. In this case, we have 1 less than W. For the next one, we have a plus sign. So you can use the sum of, or more than, or add, or plus. In this case, let's try this again. Okay, let's go back up again. All right, so we have 81 increased by the product of 2 and x. So 81 increased plus by the product, we're multiplying 2 and x. Next one, we have a fraction, and then we have a power, and it's 3. So we would write the product, because we have a number and a variable, product of a third and a cube, a cubed. Next one looks like a division symbol. So we have this term, but notice that we have the number and the variable, so they're being multiplied to each other, and then being divided by 5. So we would write the quotient of 6 times a number cubed and 5. So this is one number, 6 times a number cubed. You don't know what that number is, so you can say a number, and 5. For the next one, we have 2 terms. They're being added to each other, but these 2 are being multiplied to each other. So we can write 2 times the number squared added to 4. Added means what it is. You're adding. This one is a power, so that 2 is being raised to the power of 2. You could also say 2 squared. You just add in 2 numbers. This should be easy. 6 plus 10, or 6 increased by 10, the sum of 6 and 10. This one you could write in other ways too. You could say n less than 30, or 30 minus n, 30 decreased by n, or 30 diminished by n. There's many ways. And a few, we have n squared, or n raised to the second power. We've got n more than 6, or 6 plus n, and added to 6. We have 23 diminished by 5, 23 minus 5, or 23 decreased by 5. And the same thing with a. We have the difference of a and 9. You could also use that. Just like you say the sum of 5 and n, you could say for a and not a minus 9, the difference of a and 9, or you can say 9 less than a, or a minus 9. Whatever, in order, you can translate it different ways. Just like with languages, you could translate an English statement into many ways in your own language. All right, so it says, what do these algebraic expressions need? So what do they need? They need operations. So when we look at these two, verbal expression, in order to turn it into algebraic expression, we need to have the operation. So I'm going to write it down. I'm going to put operation. And these operations are like plus, minus, the multiply symbol and the division symbol. And of course, you need them because it tells you what operation is happening. I'm going to put what operation is occurring between the terms or in the expression. All right, so they need those operations because then it tells us how to treat the problem and how to solve it. So it says 3 times, we know that's multiplying, the sum of these two numbers. So then it'd be 3 times plus 2n. Now we have the difference. Difference is subtraction of 8, x and 7 divided by 5. So the difference between these two numbers, so that's x minus 7, and you divide it all by 5. So without these operations, you wouldn't have an expression. It would just have numbers floating all over the place. You don't know where to go with them, what to do with them. They'll be just waiting for something to happen. So you need to have operations because it tells you what is occurring between, what's happening between the two terms, the relationship between the two terms, or the expression itself. All right, so the last one, we have two kids, Consuelo and James. They're writing an algebraic expression for the verbal expression 3 times the sum of n squared and 3. We want to know, is either of them correct? And of course, explain your reasoning. So let's look at Consuelo. He has 3, and then he has the n squared plus 3 in parentheses. James has 3n squared plus 3. There's no parentheses. So let's see what it says. 3 times. All right, I see a 3. I see 3 times. 3 times. So I'm going to put 3 times, whatever it is. The sum. The sum is plus. Plus, that means we're going to be adding 2 or 3 numbers. But in this case, there's 2 numbers, a variable, a number, or 2 variables. So it says the sum of n squared. Squared, we know that it's the power of 2, and 3. All right, so let's see if Consuelo got this. It says 3 times the sum of the two numbers. So these two numbers, this one is squared, is being added to each other. So it looks like Consuelo's on the right track. Let's see what James did. It looks like he multiplied the 3 and the n cube, but wait a minute, they didn't say anything about cube. So we know that James is not correct and Consuelo is correct. Because if we were to translate this, this would be the product of 3 and n, a number, can use a number, cubed, the product of 3 and a number cubed, what can I say? Added by 3. I know I should have spelled out 3, but hey. So that's what this is translated to. This works with this one, so as we said, Consuelo is correct. Right, so we've come to the end of this lesson, and we're going to do a recap. Oops, let me go back. So we've learned all the, I know it's tiny, we learned all the vocabulary dealing with algebraic expressions and algebraic expressions and translating. So we learned about algebraic expression itself, variables, terms, factors, products, power, and power is composed of base and exponent. Product is composed of factors, 2 or 3 numbers multiplied to give you the result, which is the product. With algebraic expressions, you have variables and you have terms. Variables could be combined with letters, combined with numbers, which creates a term. It could be a number or a variable can stand by itself and be just a term. You could have 2 or 3 or 4 or many terms to create an algebraic expression. And we also learn verbal expression. Basically, you have an algebraic, you turn it into a verbal expression. That means words. And then there's different clue words that you can use in order to translate it to addition, subtraction, multiplication, and division. So we did a few examples of that. Again, it's something that you have to do practice in order to get used to. It becomes second nature. Alright, so this ends our lesson, and I'll see you next time.